So in this video, we're going to be looking at solving quadratics using square roots again, but this time around we might encounter some negative roots, and so we'll have to use some imaginary numbers to help us out. Alright, so let's get started here. Now, we're going to do this as we normally would and try to get the x squared by itself, so I need to move over the 48 because it's the furthest thing away from the x squared, whereas the 3 is sitting next to it, so I can wait to move that. So if I move over the 48, I need to subtract 48 to both sides, so that cancels. And I have 3x squared that comes down and negative 48 that comes down. If I divide by 3, the 3's cancel and x squared comes down. Negative 48 divided by 3 is negative, let's see, that would give us negative 16. And so if I were to take the square root, I am dealing with a negative root. So the 2 and the root cancel. X comes down. Now, because this is a negative root, I know I'm going to have an I. The square root of 16 is 4, but I need a plus and minus sign because in this case I took a square root, so I have a plus and minus. So I took the square root of 16, which is 4. I saw the negative, so I know I'm going to have an imaginary number. So essentially what this is saying, the x that makes this the solution for this equation is an imaginary positive 4 and a negative imaginary 4. Now for this one here, if I want to get the x squared by itself, I'm going to do something similar. I'm going to subtract over the 10 to try to get the x squared on its own. 2x squared comes down, 0 minus 10 is negative 10, divide by a 2, that would cancel that part out. X squared comes down, and I would have a negative 5, because negative 10 divided by 2 is negative 5. If I take a square root, the 2 and the square root cancel, so x comes down. But 5 does not break down into anything. 5 is not a perfect root. So I have to keep it under a root. And because there is a negative here, I know this is still an imaginary number, and I still need a plus and minus sign. And there we go. So quite a few steps to remember is that we need the plus and minus sign if we're taking a square root, and if there's a negative under my root, I need an I. This next one here, I have a something in parentheses, so I can't distribute this 3 inside because there's a square here, so I'm going to have to move as much off of it until I get the square on its own so I can take a square root. So I'm going to have to subtract over 27. That cancels. 3x plus 5 comes down, and that would be negative 27. So if I divide by 3, the 3's cancel, and so x plus 5 squared comes down. Negative 27 divided by 3 is negative 9. So if I were to take the square root, the 2 and the root cancel, so I have x plus 5 that comes down. And then negative square root of 9, let's think about it for a moment. The square root of 9 is 3, but because I have a negative, I need an I, but I need a plus and minus. So from here, what I can do is I can split it up into 2 equations. I could do that, or I could just move the 5 over because I know this 5 won't combine with the I. So if I were to subtract 5 over, I could actually write this as x equals negative 5 plus and minus 3i. So you can write it this way instead if that's a little bit easier for some of you guys. Instead of trying to break it into 2 equations, you can write it as 1 equation, and this is perfectly fine. So this is just another way of solving. Alright, that is it for the video. In the next video, we'll look at something called conjugates.